Hi everyone. Coronary heart disease, or CHD, is anything that affects the two main blood vessels coming off the aorta, as you can see here and here. There are many factors that can affect CHD. The main ones are smoking. What we can see here is open heart surgery. They have literally used the paddles there to crank the chest open so they can work on the heart. That's obviously an anti-smoking advert there, the sort of thing you see on a cigarette packet. So smoking is a massive risk. It's 2 to 6 times more likely to suffer a heart attack due to this. And it's due to two things, really. Carbon monoxide, which binds irreversibly to the hemoglobin, and also nicotine, which promotes adrenaline production. Both of these will lead to the heart having to beat faster or harder to pump blood round, which means there's increasing pressure. The other thing nicotine does is it makes red blood cells sticky. There's no real official term for it that we need to know, which increases the risk of many factors such as thrombosis, strokes, and myocardial infarction. We'll cover those in a bit more detail later. As we've seen, all these effects are linked to pressure, which is a major risk factor as well. It's often referred to as the silent killer because people don't know they have it. And it can be caused by many different factors there, genetic being one of them. What it means is the heart has to work harder, basically pump harder to force blood round, which can in turn lead to bursting of blood vessels. The correct term for that is aneurysm. If that happens in the brain, it's a stroke. And that is because there's more pressure on the artery walls. What they have to do is they have to thicken to withstand the pressure, and that can in turn harden them, which restricts blood flow. Another thing that can restrict blood flow is cholesterol. There are two types of cholesterol, often referred to as good and bad. Not really good terminology there. Much better is high density lipoproteins, which you can see there, which help to remove cholesterol, and low density lipoproteins. They're officially the bad ones because they actually deposit cholesterol into the lining of the artery. As you can see in the picture there, you've got the cholesterol particles there, as the little yellow circles, and they're invading the wall of the artery there, and that causes it to thicken and become rougher. Again, we'll see atheroma in a little bit more detail in a few moments. Also, don't forget cholesterol is vital for the maintaining of the fluid mosaic membrane. It basically forms the cell membrane or holds the cell membrane together. These high and low density lipoproteins are a little bit complex, but I found quite a nice diagram that represents it. Basically, the high density lipoproteins got lots of protein in them, therefore very little cholesterol. They can then carry that cholesterol straight to the liver, whereas the low density lipoproteins have got a lot more cholesterol in them, low density of protein effectively, and they can actually deposit the cholesterol into the bloodstream, where it can then invade the artery walls. The following picture really nicely represents this. I always think of low density lipoproteins as like an old worn out car that can't steer very well and crashes into loads of different things as it's going down the road. That's pretty much like low density lipoproteins. They hit the lining of the artery wall and they deposit cholesterol there. But the high density lipoproteins, they're pretty much like a high performance sports car. They can zip through the city streets, or in this case, the arteries, until they get to the liver where they can deposit the cholesterol, effectively cleaning, for want of a better term, the blood vessels. The final factor we need to consider is diet. Diet can directly and indirectly increase risk. There are many different things to do that. Directly through maybe the use of cholesterol and stuff like that, and indirectly such as high salt, which leads to high pressure, which indirectly increase risk. So this is kind of reiterating what we've already said. There is also antioxidants and non-starch polysaccharides, basically what we call fiber. They both help to reduce risk. So I'd just like to look at a few effects that can be influenced by these risk factors. The first is atheroma or atheromatous plaque. This hole here actually is the lumen of an artery. This fatty deposit here is the lining that's built up with fat. This person would be dead, unfortunately, from this because that's a cross section through their artery. What happens is the fatty deposits form in the artery wall and start to build up. And what they do is they form streaks, which become embedded in there. Now, the body tries to get rid of these and sends white blood cells to the area to engulf and digest these fatty streaks, but unfortunately, they get stuck as well, and they become things called foam cells, which pad out the lining of the artery, therefore forming atheromatous plaque, which can impede blood flow, and we end up with a narrowing of the arteries. If it happens in the heart, that can cause a heart attack, which we'll look at in a few moments. One key bit is the atheroma never furs up the arteries themselves. It never sort of blocks the lining. It goes into the walls and fits there. Atheroma can lead to the formation of a thrombus. The thrombus is a blood clot within the artery. As you can see, the yellow lining here is where the atheromatous plaque has built up. That causes a rough surface, which platelets can stick to, which in turn cause red blood cells to stick to, and that can form a clot. This in turn leads to thrombosis. The thrombus, the clot, it's sometimes referred to as an embolism as well. So the atheroma blocks the artery, which then causes the thrombus to form. That can then reduce blood supply to the area, starve the area of oxygen, glucose, and that can cause it to die. The most common one of these is deep vein thrombosis, which people have probably heard of. It's caused when you sit down for too long on plane flights and stuff like that. And what happens is the blockage can form within the leg there by one of the valves and can break off. That can then travel to the heart, block the coronary arteries, and cause a heart attack. Before we get to heart attacks, we've just got to look at one more effect, and that is the aneurysm. Aneurysm is swelling of a major blood vessel. It can cause multiple effects. It first off weakens the artery walls by causing a blockage, so the blood has to go round it, a bit like if you chuck a boulder into a stream, it'll actually overflow the banks and flood round it. And that can cause the swelling, which is the aneurysm. You've got two forms, saccular and fusiform. Don't need to know those terminology, but the worst one is if that can burst or hemorrhage, so a ruptured aneurysm. If that occurs in the brain, we end up with what's commonly called a stroke, but is correctly termed cerebrovascular accident. Cerebro of the brain, vascular blood vessel, accident, it broke. So if the thrombus arrives at the heart or the blockage occurs in the heart, we can end up with a myocardial infarction or a heart attack. The other thing that can cause this is build-up of atheromatous plaque within the coronary arteries there. So it causes a swelling in the walls, which reduces blood flow. Either way, this could impede supply of oxygen to the area beyond. So the myocardial infarction is pretty much just heart interrupted, and it means that oxygen supply in the heart is reduced. There's two kinds, really. The top layer would be incredibly bad. That would be fatal because the whole area beyond where the blockage is would be starved of oxygen. So either way here, half the heart is effectively going to be starved of oxygen. That's incredibly bad. The second kind is not as detrimental. It's still really bad, but is classed as a milder heart attack because only a small region of the heart is impeded. It can return to function, but there may be some scar tissue which means the heart doesn't function as well as it should. To finish off on, we just need to look at ECGs. Don't need to know a huge amount of detail about them, just that they're used to trace the electrical output from the heart, which we're going to look at in another lesson. And during normal activity, we end up with the classic sort of beep, beep line that you see in medical dramas. Contrary to popular belief, a heart attack and death is not a flat line. A heart attack actually inverts the peaks and the troughs. They actually flip completely around. And what's actually happened in this case is the person started the heart attack there, and actually the heart recovered and continued there. So that was a myocardial infarction. And if we end up going into what's classed as the true heart attack, we end up with fibrillation, which is where the heart chaotically tries to compensate. What happens is we end up with the regular chaotic ECG, and you need to defib it, which is effectively stopping the heart, restarting it with electrical impulse, which will hopefully shock the heart into returning back to the normal regular pattern there. Flatline is a bit of a myth, doesn't actually occur. The only time you get that beep is where someone has unplugged the machine. But for medical dramas, it looks great. Thank you.